All right, so this is an overview of linear programming. So in this first problem, remember senior wants to get all the seniors to the movie theater. You can rent vans or buses. Vans hold 10 students, buses hold 40. There needs to be enough seats for 240 seniors. Additionally, the company only has 12 drivers. If the van costs $125 and a bus costs $450, find the combination that minimizes the cost. So the first thing we need to do is we need to write our objective function. The objective function is just a fancy name for the thing that we are trying to maximize or minimize. So in this case, we're trying to minimize the cost. So we're going to write the cost as a function of our two variables. The two variables are the amount of vans and the amount of buses, because that's the thing that we can adjust. We're going to say x is the number of vans, y is the number of buses. And the cost is going to be the cost per van times the number of vans, 125x, plus the cost per bus times the number of buses, 450y. And then our constraints are that we need 240 seniors. So the total number of seats needs to be greater than 240. And the total number of seats we can model as the seats per van times the number of vans, plus the seats per bus times the number of buses. Our second constraint is that we can only have 12 vehicles in total. So the total number of vans plus the total number of buses has to be less than 12. And then finally, both of these technically have to be greater than 1. We usually ignore that constraint because it's kind of obvious. You can't have a negative number of vans, greater than 0, because you can't have a negative number of vans or buses. But that just means that we're above this, to the right of this line and above this line, so we kind of just ignore it. We're going to focus on graphing this constraint over here and this constraint over here. So we're going to subtract x from both sides. 40y is less than 240 minus 10x, divide by 4. Y is less than 6 minus 10 over 40 is 1 over 4, x over 4. Second constraint, we're just going to subtract x from both sides. And, sorry, I made a mistake over here. This has to be greater than 240, which means this has to be greater than this, which means this has to be greater than this. It has to be greater than 240 because the number of seats has to be more than 240. The number of vehicles over here has to be less than 12 because there are only 12 drivers. So this is y is greater than 6 minus x over 4, and the other one is y is less than 12 minus x. So we have intercepts of 6 and 12, so we may as well make our thing by ones because the numbers are pretty small. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then that's pretty much it. So for the first one, we're going to start at 6, and based on our slope, we're going to go 1 down, 4 to the right. 1 down, 1, 2, 3, 4. Oh, and the same thing over here. 2, 4, 6, 8, 10, 12, 14, 16, whatever. That's probably enough. 1 down, 1, 2, 3, 4 to the right. 1 down, 1, 2, 3, 4 to the right. 1 down, 1, 2, 3, 4 to the right. 1 down, 1, 2, 3, 4 to the right. And we need to be above this line over here because y has to be greater than this. So we care about this area up here. This is for the first constraint. Our answer needs to be some point from this area over here based on that constraint. Our second constraint, in order to graph it, we're going to start at 12 and we're going to go 1 down, 1 to the right. 1 down, 1 to the right, 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 etc., etc., etc. And we need to be below this line, so it's going to be this area over here. So the feasible region is the area which is highlighted by both of them. Our possible answer is going to be somewhere in this part of the graph right over here, which means that we care about, the points that we're going to test about are the 3 vertices of that particular point. This vertex, and this vertex. So those 3 vertices have coordinates of 0, 12, 8, 4, and 0, 6. So we're going to test each one. Now, using some very, very basic logic, we can rule out 0, 12, because by definition, if you get 12 buses, that's obviously going to cost more than getting 6 buses. So we're just going to test 8 vans, 4 buses versus 0 vans and 6 buses. So the cost of 8 vans and 4 buses is, based on our objective function up here, it's 125 times 8 times 8 plus 450 times 4. And that gives us, let's do some very basic math over here. 125 times 8 is 1,000, I believe. Go away. 125 times 8 is 1,000, and then 450 times 4 is so this is going to be 28,000 because the other one's 1,800. And then 0 times 125 we can ignore. And then 450 times 6 is just 2,700. So that means that this is the cheaper option, and that is our answer. It's 6 buses, 0 vans, and we get $2,700 is our minimum cost. And that is our answer. Next, Leo wants to attend as many baseball games as he can. Bundle A allows for 7 games and costs $100. Bundle B allows for 3 games and costs $50. Bundle A is limited to 4 per customer. Bundle B is limited to 8 per customer. Leo is allocated only $600 to spend on this endeavor. So find the combination of bundles that Leo can purchase to maximize how many games he can attend. So we're finding the combination of bundles. So that our 2 variables are going to be the number of bundle A's and the number of bundle B's. And the thing that we want to maximize over here is not cost, it's how many games he attends. So his number of games is going to equal the amount of bundle A's he gets times 7 plus the amount of bundle B's he gets times 3, because each bundle A lets him go to 7 games, each bundle B lets him go to 3 games. So this is what we're trying to maximize. In this case, cost is a constraint. The reason why cost is a constraint is because Leo has a fixed amount that he's allowed to spend, which is $600. So that means the total amount that he spends, aka 100x plus 50y, has to be less than 600. Because the amount he spends on bundle A is going to be 100 times x. The amount he spends on bundle A is going to be 100 times x. The amount he spends on bundle B is going to be 50 times y, and that has to be less than 600. And then there are 2 other constraints. Bundle A is limited 4 per customer, so the total number of bundle A's has to be less than 4, and bundle B is less than 8 than customers, so the total number of bundle B's have to be less than 8. So we're going to graph these. Y is less than 8 is just here, let's do the other one first, just so we can get a sense for our axes before we start graphing stuff. We're going to move the 100x to the other side. 50y is less than 600 minus 100x, divide everything by 50. Y is less than 600 divided by 50 is 12 again, 12. And then 100 divided by 50 is just 2 minus 2x. So we have 12, we have 8, and we have 4, so we can go by ones again. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12, 14, 16, 18, etc. So y is less than 8. So y equals 8 is this line right over here. And we're less than, so we care about this region over here. X is less than 4 is this line over here. So we care about, let's make this a different color, this region over here. And then finally, y is less than 12 minus 2x means we're going to start at 12. And our slope is negative 2 over 1, so we're going to go 2 down, 1 to the right, 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 2 down, 1 to the right. And then less than means that we're going to shade this region over here. So the area which is shaded by all 3 is this shape right over here. So the vertices that we're going to test are this guy, is this guy, this guy, this guy, this guy, and technically that guy, even though obviously 0, 0 is not going to maximize it. So the real possible candidates are 0, 8, 2, 8, 4, 4, and 4, 0. And just like last time, so this is 0, 8, this is 2, 8, this is 4, 4, and this is 4, 0. Just like last time, we can pretty easily rule out 0, 8, and 4, 0. because 2 comma 8 is going to be more games than 0 comma 8, and 4 comma 0 is going to be obviously be less games than 4 comma 4. So we really care about is 2 comma 8 and 4 comma 4. So 2 comma 8 allows us, based on our function up here, to go to 7 times 2 plus 3 times 8 games. 7 times 2 plus 3 times 8. So 7 times 2 is 14. 3 times 8 is 24. 14 plus 24 is 38. And then 4 comma 4 is 7 times 4 plus 3 times 4, which is 28 plus 12. 28 plus 12 is only 40 games. Is 40 games. So therefore, the 4 and 4 option is going to maximize the amount of games they can go to. So buying 4 of bundle A and 4 of bundle B satisfies all of our constraints and allows them to go to 40 games. So that would be our final answer.